Here you can see the three-dimensional view of the building. The Energy Model Review palette is already visible on the right side of the screen, and with the help of this palette, we can automatically turn the ArchiCAD building information model to a building energy model. EcoDesigner Star performs very accurate multiple thermal block energy balance calculation. Thermal zones are used to identify and visualize the spaces or zones of the building. These zones are grouped by functions or occupancies and are necessary to perform high-accuracy energy simulations. Let's click on the names of the thermal blocks in the Energy Model Review palette. Please note that the corresponding zones will be instantly highlighted in the 3D view on the left. For example, here you can see the entrance area highlighted in the 3D view. Now let's select the glazed multi-story atrium represented by the circulation thermal block. There are some other circulation blocks, and then you can see the staircase, as well as the elevator thermal blocks in the list, also highlighted in the 3D view. There are separate thermal blocks created for the laboratories to reflect their location and orientation within the building, because these need to be considered separately throughout the calculations. This building is rather complex. It contains 20 different thermal blocks. The geometry of the thermal zones has been automatically derived from the ArchiCAD building information model. Thermal blocks groups 3D zones having similar orientations, operation schedules, and MEP systems. Here you can see all the thermal blocks selected and highlighted in the 3D window. Let's switch to the Structures tab page of the Energy Model Review palette. Here we can take a look at the building energy model from a different perspective. Let's select all the thermal blocks in the list. The different parts of the building are color-coded according to the relevance in the energy calculation. Different shades of brown represent the opaque external building shell. The different shades of green represent the internal structures of the building. Shades of the color blue represent those structures that are in direct contact with the ground. Let's switch to the list view on the Energy Review palette to display all the properties of the individual building structures that are considered throughout the building energy calculations. Here you can see all the element information that is taken off from the ArchiCAD BIM model, and also view other energy calculation related input that are considered throughout the energy analysis. All these values and properties can be modified or customized, and the corresponding building elements can also be instantly visualized in the 3D view. Most of the other building energy software applications require users to remodel the building from scratch and to manually provide such calculation-related element properties. This requires a lot of time and money. EcoDesigner Star automatically subtracts all energy calculation-related element data from the ArchiCAD building information model. It can also export all the analysis-related data for other applications using a series of different formats, including GB XML, IFC, PHPP, SBEM, as well as VIP energy. The industry standard GB XML format is also supported. This format is used for both the import and export of the building energy model. Let's switch to the Thermal Blocks page of the Energy Model Review palette and select the Science Thermal block from the list once again. The Thermal Block property page below the list displays information about the so-called supply building systems of the selected thermal block. Practically, this represents the heating, cooling, and ventilation systems used in the selected thermal block. This information must be added separately to every thermal block before starting the energy calculations. The Building Systems dialog can be used to adjust the basic properties of these systems. Thermostat-controlled heating and cooling means that there are minimum and maximum allowable temperature requirements for a thermal block. The free-float system type does not have the constrained temperature requirements. It allows the internal temperature to act as it would without any constraints. The ventilation type and characteristics can also be adjusted by using the required ventilation type from the pop-up list and adjusting its system parameters numerically. For instance, we can select the supply and exhaust ventilation type and then open its operation schedule. Here we can define when to turn on and off the ventilation system and also specify the air change time and date ranges, as well as its recurrence intervals. Here, for example, we can define the characteristics for night ventilation. Such building systems and energy settings can be individually adjusted for each and every thermal block in the building. Let's proceed and have a closer look at the operation profiles. The available operation profiles are listed at the top of the dialog. Here we can edit these existing profiles and also create new operation profiles. Let's select the existing personal office operation profile by clicking its name in the list and review its settings. Let's open the Daily Profile Editor to review and edit the workday and non-workday related profile data. Let's select the Workdays entry at the top of the dialog first. The internal temperature and internal heat gain charts are represented by colored diagrams. The maximum and minimum internal temperature requirement before and after the daily working hours is loose, between 28 and 15 degrees Celsius or 82 and 59 degrees Fahrenheit. During the working hours, the temperature values are more regulated and set to be in the interval of 26 to 26 degrees Celsius or 68 to 78 degrees Fahrenheit. This is the period of time when occupancy occurs, emitting metabolic heat, and during this period, all the lights and equipment are on as well. All these effects are considered throughout the building energy calculations on an hourly basis. Let's select the non-workdays entry at the top of the dialog. Here you can see a slightly different scenario for the internal temperature and internal heat gain profile. Please note that all these profiles can be manually customized to reflect the actual occupancy characteristics of the building, considering national holidays as well as other events. Such precise scheduling of operations is a prerequisite for accurate energy calculations. Let's proceed and review how the model-based solar irradiation study is created by Eco-Designer Star. We'll open the Openings page of the Energy Review palette and switch to the List view to display all the properties of the transparent structures in the project. Let's select all the openings of the middle circulation space. This is the atrium area that cuts through the building. It has some openings at the top and also has some additional internal openings. All these openings are highlighted now in the 3D view on the left. Now let's select two seemingly identical windows from the list. One is on the northeastern side of the building, and the other has a southeastern orientation. The sizes of their glazed areas are approximately identical. The only main difference between the openings is their orientation. Let's see how this difference in orientation affects the solar irradiation of these openings, which will also affect the building energy calculations. Let's select the opening with the northeastern orientation and open the Solar Analysis dialog. Here we can visualize the solar irradiation of the opening. The first diagram represents the percentage of glazed area exposed to direct sunlight. The horizontal axis displays the months of the year, and the vertical axis displays the hours of the day. When hovering over the graph with the mouse, the hourly values are displayed for the selected date and time. The large blue area means that this window is mostly shaded throughout the year. It receives a bit of sun only in June in the early morning hours. This is represented by the yellow area. Let's switch to the direct solar radiation on glazed surfaces diagram. Here we can read the direct solar radiation values for the same time interval. This incorporates the weather data for the location of the building as well. The total annual integrated direct radiation values for the selected opening is below 5 kilowatt hours. Let's select the other opening having the southwestern orientation and open the Solar Analysis dialog once again. It's immediately visible that this opening receives much more sunlight throughout the year, mainly during the afternoon hours. Here, the yellow area is much larger than in the previous opening. The second diagram displays that annual integrated direct irradiation is over 320 kilowatt hours. Please note that the magnitude of difference in direct solar radiation between the two openings is exceptional. This solar radiation information is considered throughout the building energy calculations. Let's proceed and have a closer look at the thermal bridge analysis functionality of EcoDesigner Star. This feature greatly helps designers identify those details in the design which are responsible for heat loss and might cause vapor condensation as well as other unwanted effects. ArchiCAD derives building details directly from the building information model. Here you can see a typical detail of the laboratory building. We'll perform a thermal bridge simulation for this detail. The simulation is pretty straightforward. All we need to do is to select the detail in the view map of the navigator, and then activate the Thermal Bridge Simulation option from the context menu. The Thermal Bridge Simulation wizard opens. First, we must specify the external air areas by clicking on the preview image. Let's select these two areas for the external air, indicated by a dark color, and then click the Next button to proceed. Now let's define the internal air area in the same manner. The internal air is represented in red in the preview image. Let's click the Next button to proceed. Currently, we do not have any soil or ground area, so we can skip identifying its area by clicking the Next button. Here, all the used cut fills of the detail are listed. We can assign thermal properties to all of them. By clicking on the name of the cut fills in the list on the left, the corresponding cut fill in the preview image on the right will be instantly highlighted. The thermal properties can be reviewed and also modified. The rich material catalog provides great help for designers. Here, all materials are listed with relevant thermal conductivity, density, and heat capacity values. Of course, custom thermal properties can also be specified for the cut fills. Finally, we are ready to perform the simulation. We can display the simulation grid contours on the previous image. EcoDesigner Star uses a variable grid technology to determine the simulation points. The thermal bridge simulation can be started by clicking the Start Simulation button, and the results are displayed in just a second. The simulation results can be displayed as a temperature or energy flow diagram. Let's display the temperature diagram first. We can hover the mouse over the diagram to display the exact temperature values at any given point of the detail. Let's display the energy flow diagram now. It's clear that the most intense energy curves can be located at the triple glazed window panels to frame connection. The energy performance or psi value automatically calculated for the detail is very low, below 0.5 watts per meter Kelvin. Let's proceed and review how to create and customize energy performance evaluation reports. Here you can see a PDF report created by EcoDesigner Star. Let's have a closer look at the results. Here you can see the key values of the energy demand calculation. Here are the specific annual demands. It's clearly visible that there is no cooling energy required, however there is a rather high heating energy demand. Let's scroll down to have a closer look at the details of this energy demand. Here you can see all the thermal blocks of the building. Let's scroll further to display the energy performance evaluation diagram. The different bars here represent the energy flows. The top chart displays the supplied energy per week to maintain the internal comfort. At the bottom, you can see the diagram of energy losses. It's clear that the highest amount of energy loss is due to the natural ventilation. This must be counterbalanced by heating. The good news is that about 80 to 85% of this energy loss can be regained by installing an air-to-air energy recovery system into the exhaust air system of the mechanical ventilation units. Let's scroll further down and take a look at the daily temperature performance diagrams. These inform us of the exact hourly temperature values in the building for any referenced days we wish to know. Here you can see the temperature diagrams of the West laboratories. Let's switch back to the ArchiCAD model to highlight this thermal block in the 3D view. Let's return to the diagram. The comfort zone in this space is indicated by the darker red area in the diagram. The light blue line represents the internal temperature values. The dark line below indicates the external temperature on January 15th. The temperature difference must be compensated by a heating system that requires additional energy. Let's have a look at the temperature values in the same laboratory during the summer days. You can see that during the summer days, the external temperature can be even higher than 20 degrees Celsius or 68 degrees Fahrenheit in Britain during the afternoon hours. Let's take a look at the circulation spaces that have the so-called free-float heating and cooling systems. Here you can see the circulation thermal block, the main central atrium of the building, highlighted in the 3D view. In January, the internal temperature of the atrium will remain very low without any heating. During the spring, the temperature of the atrium is higher, and the values are getting closer to the thermal comfort values represented by the red area in the diagram. In July, the internal temperature of the atrium, even though it's free-floating, is still within the comfortable range. In the winter, once again, the internal temperature drops back down. Please note that the content of this PDF report can be modified. Any thermal blocks on any day can be displayed in the report. Besides PDF reports, Excel spreadsheets can also be created, and their content is also highly customizable. All the input as well as output information of the energy simulations can be displayed in the Excel diagrams. Please note that at the end of the day we might come up with only a handful of results. However, these results are achieved through numerous calculations considering various properties of the building energy model. Here, for instance, you can see the annual integrated maximum and minimum temperature of a thermal block. And the integrated peak heating and sensible cooling loads are also calculated. This is the type of information that can be passed on to engineers who can use this as input to size the heating and cooling equipment.